Hey guys, Mr. Milton here. Today we're going to talk about parallel lines. At the end of this video, you should be able to identify parallel lines from characteristics in their equations, and you should be able to write the equation of a line given the information about a parallel line. Alright, so let's start with a little bit of a review, slightly, by graphing these two lines. Okay, our first line's in slope-intercept form. We can graph that by starting at the y-intercept, which is 6. 1, 2, 3, 4, 5, 6. And then our slope is negative 3/4, so I'm going to go down 3, 1, 2, 3, over to the right 4, 1, 2, 3, 4. Try to do that again, but not enough space on the graph to do it, so I'm just going to use these two lines, connect them, and a line through there. Alright, so my first line there. Alright, since I have a different color available, I'll use a different color for my second line. Okay, my second line is written in standard form, but as I look at it now, I'm really not going to be able to get two good intercepts, so I'm going to change this into slope-intercept form. I'm going to do that by solving for y, so I'm going to subtract 6x from both sides. I'm going to write it up here. I have 8y equals negative 6x plus 16. Divide by 8 to get y all the way by itself, and so then I'll get y equals negative 6/8 x plus 2. I'm going to simplify negative 6/8 into negative 3/4. So y equals negative 3/4 x plus 2. Alright, with that information I can graph this line. My y-intercept is 2. My slope is negative 3/4, so I'm going to go 1, 2, 3, over right, 1, 2, 3, 4. I could go up 1, 2, 3, and to the left 1, 2, 3, 4 as well. Alright, make a line through these points. And there we have it. Our two lines. Okay, so what do these two lines have in common? If you look at their equations, what they have in common is that they both have slope of negative 3/4. Okay, what's different about these two lines? Again, looking at the equations, we can see that the y-intercept for this line is positive 2. The y-intercept for this line is positive 6. So the y-intercepts are different. So, in order for two lines to be parallel, this is what they have to have. Parallel lines have the same slope and different y-intercepts. Alright, and so that's what we'll use from here on out to identify parallel lines. So in this next set of questions, it's saying determine whether the given lines are parallel or not, then explain. So again, since parallel lines have the same slope and different y-intercepts, that's what we'll be looking for. Like, do they have the same slope, or are they different y-intercepts? So first problem, okay, notice that we have one already in slope-intercept form, so we can identify that the slope is 2. The y-intercept is negative 1. Typically how these problems will be set up is that one of them will be in slope-intercept form and the other will not be. And we need to make sure we change it to slope-intercept form before we try to identify the slope and the y-intercept. Okay, the slope is only the number by x when y is by itself. So now this is in standard form. We don't know what the slope is yet. We need to get y by itself. We'll do that by subtracting 2x from both sides. Y will equal negative 2x plus 3. Okay, and now I can say, hey, my slope is negative 2. My y-intercept is 3. Okay, are these parallel or not? The answer in this case is going to be no. These two lines are not parallel because the slopes are different. They're not the same. Okay, this slope is 2. This slope is negative 2. Not the same. Okay. Second problem, we are given that our slope is 5/2 and our y-intercept is negative 4. And in this first equation, I need to get y by itself. So I'm going to do that by subtracting 5x from both sides. And so I have negative 2y equals negative 5x plus 8. Then I'll divide by negative 2. And so I'll get y equals 5/2 x minus 4. Okay. Alright, so now I can see that my slope here is 5/2. My y-intercept is negative 4. Are these lines parallel? Okay. In this case, the answer is no. Okay. Even though the slopes are the same, they have the same slope and same y-intercept. Okay, for parallel lines, we need to have different y-intercepts. Otherwise, these lines will touch. If they're the same slope and the same y-intercept, what will happen is that we'll have two lines laying right on top of each other. Okay, and so this is a no here. I'm going to leave number 3 for you guys to do. Try that out just as we have for these other two. Identify the slope and the y-intercept, and then compare them to each other. Remember, parallel lines must have the same slope and different y-intercepts. Alright, so here's our process. The next section, is going to say write the equation of the line parallel to y equals negative 3x plus 4 that goes to the point 7, negative 2. So we're going to be right now writing an equation for a line, sort of like what we did in previous sections. But here's our process. We want to find the slope of the original line. We want to find the slope of the new line. And then we're going to find the y-intercept using the point that they gave us. And then write our equation. So, find the slope of the original line. In this case, it's pretty simple because our line's in slope-intercept form. We know that our slope is negative 3. The directions tell us to find write the equation of the line parallel, okay? And that's the key word here since we know that our lines are parallel. Parallel lines have the same slope. And so, the slope of our new line is going to be negative 3 as well. And now we're going to find the y-intercept using the point. So, I know that my slope is negative 3. I know that my point is 7, negative 2. So now I'm going to plug it into slope-intercept form. Negative 2 for y, negative 3 times 7 plus b. So I plug 7 in for x. I plug negative 2 in for y. Remember, that all comes from the slope-intercept form equation. And now I'm just solving for b. So I have negative 2 equals negative 21 plus b. I'm going to add 21 to both sides. And that's 19. So b is 19. So now I found the y-intercept using this point, and now I write the equation. I have m, which is negative 3. I have b, which is 19, and so I have y equals negative 3x plus 19. And there's my equation. Okay, you can try this on your own if you'd like to, and then pause it and come back and see how I do this. I'm going to do this problem right now. Okay, it says write the equation of a line parallel to 2x minus 4y equals 11 that goes to the point 6, 1. Okay, the last problem, they gave us the y-intercept, the slope pretty simply because it was in slope-intercept form. Here we need to find or put it in slope-intercept form before we find it. So I'm going to solve for y, subtract 2x from both sides, So negative 4y equals negative 2x plus 11, and then divide by negative 4. And so y will equal negative 2 divided by negative 4 is positive 1/2, x minus 11/4. Okay. Alright, so this fraction here really won't affect us because we really don't care what b is for this original line. It doesn't matter to us. What does matter to us is what the slope is. Our slope for our new line will be 1/2. Okay, and so now since that's our slope, we have this point 6,1. I'm going to do my work over here, more space without running into where I'm going to write my answer. I'm going to have, again, y equals mx plus b. I'm going to plug in 1/2 for m. The x value is 6. The y value is 1. And so now I'm solving. 1/2 times 6 is 3. Subtract 3 from both sides so I can solve for b. And b is negative 2. So now I have my slope, I have my y-intercept, y equals 1/2 x minus 2. Okay. Alright, and then finally just another way that we can write it. Instead of being given a sentence or a description, we're given a line. Does it change what we have to do? We want to find the slope of our original line. We want to find the slope of our new line, use a point for our new line, and then write the equation. So, a couple ways that we can do this here. I see visually we can find our slope a little bit easier here in the sense that we don't have to use we don't have to solve anything. I can just count. Goes down 2 to the right, 1, 2, 3. Okay, since they gave us 2 points, it might be safe to use the 2 points that they gave us. Goes down 4, goes to the right 3, 6. So again, negative 2/3. So we found the slope of our original line to be negative 2/3. Since our new line will be parallel, we know that slope will be the same, negative 2/3. Okay. They gave us this point, which is negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So negative 6, negative 5. And then from there, what we'll do is just we'll plug it in the slope-intercept form. Okay, plug in our x values, solve for b, and write the new equation. Do that for me. Write this new equation of this line. Okay, here, bring that in with your completed notes. Alright, so hopefully you've seen what lines are parallel. It means they have the same slope and different y-intercepts. You've seen how to identify the slopes and compare two lines to see if they're parallel, and now you can write the equation of parallel lines given original line and a new point. Alright, see ya.